Hey guys, just want to do another update video on the progress of the 4-foot wheel. First, I want to show you the circuit that I'm running real quick. I'm getting the fancy paper again today. So our input power comes in from our switch is on the negative side. So from the negative side of the battery, it goes to the mechanical switch. It's at the top of the wheel over there. Then it runs through the coils to the positive side of your input. I'm rectifying just across the switch on the negative wire. So theoretically, when the switch is closed, the rectifier should not receive any input from the pulse, or if it does, it's very little because it's acting like a dead short when the coils are induced. So as long as the load is there, I don't know, you'll see it when I run it. But this is the circuit that I'm running. I'm just collecting off of where the switch is at right now. So I'm not even collecting across here at all. So first, I'll show you the resting voltage of the charged batteries. It's at 76 volt, 76.1. There's 7 batteries in series. This one only has 4 volt in it. I have 2 sets of LED lights hooked up. This back set only requires about 72 volt before it starts illuminating. This front set requires 112 volt before it'll start illuminating. The 112 volt one I have hooked to the rectifier at all times, so that if I lost a connection on the charged batteries, or if, say, for some reason the charged batteries got to 112 volt, this light would start coming on and I couldn't overcharge the system if I had 112 volt worth of batteries here. If I wanted to limit it to the 112 volt, then this light would come on if it was max charged. So I'll show the input voltage. I'll be running off of, this was the power supply that came on the back side of the LED light. It puts out about 105 volt DC. I'll be showing the consumption rate on the inverter to how much power and watts we're actually using. So I've got a piece of paper in the switch right now, so when I turn it on, we can get the voltage reading that's going into the motor. So we'll do that now. The system is at rest, 0 watts. Our power supply from that light says it's giving about 106, 107 volt. Once it starts running, it won't run at that. We'll see that. So we'll give it a quick spin here. We'll pull the paper out. Instantly, the charged batteries are pushing up over 80 volt. We'll let her run up to speed a little bit real quick. So currently, that power supply says it's delivering 50 to 80 volts. The actual consumption of the power supply is about 15 watts. It'll probably drop to 10 once the motor gets up to speed. We'll give it some help here in a second. We're going to help it get up to speed so it doesn't take so long in the video. Takes a while to sling 90 pounds up to speed. We'll let it sit there for a second. So the power supply is running about 70, 80 volts now, 90. Run about 9 watts. The charge batteries are pushed up around 81, 82 volts. That is not a ghost charge, and I'm about to show that that's not a ghost charge. I'll show it loaded this LED, the 72 volt one, directly off the battery bank once. We'll light it up. We're illuminated. Charge batteries. It'll slowly come up as the lights warm up. It should run higher than the 75 volt. Still running the 80, 90 volts. Hasn't affected consumption of the motor. We're going to unhook this one again real quick. I'm going to unhook the charge batteries. This bottom LED, when this gets to 112 volts, this LED should start coming on. So I'm going to unhook it right here for the charge system. It's unhooked from the charge battery, so we're hooked to this bottom LED. It says it's delivering about 119 volts to that LED light, DC. We're going to assume it's about 100 milliamps. Input from the power supply, still around 90 volts. Consumption rate hasn't been affected whatsoever with the load. So rectifying across the switch is allowing me to draw from the system without affecting the input, is what I'm assuming. I mean, we got some pulsing with it, but that cap's a 250 volt 47 UF. So if you kind of want to know what the amperage coming out is, it's going to be 119 volt at 47 UF. I mean, you could do the math on it. I'm not going to switch the meter over to the amps yet. Like, I'm blowing too much stuff up. I'm lucky to get it to run like it's been. So I'll show the back real quick. Let me hook the charge batteries back up. The light's on right now. Oh, here we can hook this one up, which will cancel the other LED out. It changes, the impedance is different, so the load's different. It actually makes the output drop 73 volt or so. Still about the same input. Looks like it dropped maybe a little. Consumption rate. Don't look like it's affected much. Seems like how you draw off of it makes a difference. Spark gap makes a huge difference. Oh, discharge battery back up. And that power is very real, because it lit me the fuck up earlier. So our first gearbox was a complete failure. It needs a lot of work on that. But we managed to put, it's basically 11-to-1 ratio, one on the back. I think I want to try to do it another one to drop it down even more, because the water pump I've been designing takes lots of pound torque to push it down. I've tested with the compressor, the DC motor, the air compressor, a couple things, and it doesn't seem to have a problem running any of them. So if you want to kind of know what the torque is, it's going to be a 24-inch lever with 1 pound foot-pounds on the end to a 1-inch to whatever, 11-to-1, so you'd multiply by 11. If we was getting 10 pounds at the shaft, you'd have to multiply it by 11. So the charged batteries are now starting to push up a little higher. The question kind of is if you wanted to draw off of one of these batteries through the inverter, because I'm running the inverter off its own battery, which is a new battery that I got. It's a big Fleet battery, 127 pounds. It delivers 1,750 cranking amps. It has a 440 reserve capacity on it. Like just a single battery, like you can run a lot of shit off that fucker. It was like 270 bucks. So the motor's running at about 8 to 10 watts. I can get it faster. It's just a slow process time. I haven't started the second cycle. There's too much to explore with the first cycle here yet. I really like to see trying some input voltages upwards of maybe 500 volt. Like, I think I could have some super good fucking frying some stuff here. But anyways, I hope everybody likes the update. Like, I'm seeing some decent results from it. Like I said, the question is, if you wanted to draw off of one of these, how can you balance the system out without having to undo everything and run it parallel and keep running everything in series, but to get this battery, say, to come back up after you draw off of it. Like, I've tried drawing the LEDs across the system to balance everything. Doesn't seem like the voltage will go from one battery to the other that way. So if anybody's got any ideas on that, how to balance these out without having to unhook them and turn them and all that bullshit, I'd be welcome to some ideas. Anyways, thanks for watching. See you on the next video.